everybody needs a little practice or a little review or a little road test. I made this little Python road test because we're working on finite difference methods for more complicated things. And so these are just some of the basic tasks that we need to be able to do. And this is a little test. I'm going to work through the answers for this test, just like if you were taking an actual test for your driver's license renewal, whatever you want to call it. Let's just get to it. And I'm just going to start. So this first question, it says, make a list of values of x from 0 to 2 with a spacing of 0.2. Let's do it. Now, I'm over here. I'm going to use Trinket. And this is using WebVPython. WebVPython is a little bit different. You could say, I'm going to use, make this as an array. There's no arrays. And if you know what an array is, that's awesome. And arrays are awesome. But I want to use WebVPython. No arrays. We have lists. We don't have arrays. Okay, let's get to it. So I'm just going to start typing some stuff here. I want to make x go from, down here. I want to make x go from 0 to 2. So let's just start with a temporary x value. I'm going to call it x0. X equals 0. xt, I'm going to call it x equals 0. I'm going to make it even bigger. Make it even bigger. There. You can't get bigger than that. And then I need to make a step size. I'm going to call it dx of 0.2. And just watch this. While xt is less than, I guess I should call it a equals 2. While that's less than a, print xt. Now increase the value of xt. xt equals xt plus dx. And I'm going to run it. And I get my value 0 to 2 of 0.2 steps, but it's not in a list. So I need to add those to a list, and I'm going to call that list x. So in Python, we make a list with I can make an empty list with square brackets. There's nothing in there. And then I can add stuff to the list. I don't want to print this anymore. I don't really care about that. I'm going to add it to a list. X equals x plus the xt value. So I'm going to add that element to my list. And when I get done, I'll have a list of x values. We can print that out. Remember, x is a list. So, too small. Print x. Run. There you go. No, question number 1. Check. Did that. Go to question number 2. And I wrote these, just so you know. Make a list of function values. So I have a function. I want to make a function as a list. I should change that up a little bit. Make a function as a list with the same values of x as my x value, such that f of x is a sine kx, where I want a to be k to meet the boundary condition. So if I want f of 2 to be 0, which I shouldn't have done it that way, and I want a to be 1, then k would be, what would be b, or what I call a over pi. Pi over a. Yeah. Okay, so let's do that. So I'm going to make a function. I don't want to print that anymore. Let's make a function as a list. I'm going to call it f, and it's just an empty list. Now, I want to go, and I need my other values too. A equals 1, and then k equals pi over a, right? Because a is 2. And now make sure that the boundaries are met. And there's more than one solution there, and that's what we see in quantum mechanics all the time. But that's another story. So I want to go through my list of x values, right? I don't want to regenerate them. I already have my x values. I can do this. For I, and now there's a reason to do this, range the length of x. And if I print I, it'll just go 0, 1, 2, 3, 4, 5, 6, 7, 8, whatever. But I can print the x values, print x of I. And that's not the answer, right? But it will be useful. So let's print that. And there's an error. Unexpected name range. Why are you unexpected? WebVPython. For I in range. Sorry. Print that. Run it. And there's my values of x. So it did that. So that's what I want. Now I want to use those x values and calculate my function. So f equals f plus, each element based on my I is going to be a times sine k times x, which is xi, and that's it. Right, and if I want, I can print that out when I'm done, but it won't really mean too much. Now, remember, this is not normal Python. In normal Python, you couldn't do sine, right? Sine's not a built-in function, but it is in WebVPython, so we can. And one of the things I really like about WebVPython, there's a bunch of stuff, but I'm going to run this, and those are my f values. So I did it. And you'll notice that my boundary conditions are met. I have x of 0. That's my first one is 0, and my last one is 0. Yes, 5.66 times 10 to the negative 16th is 0. 0-ish, right? It's close enough. I think that meets question number 2. I made a function. Now I'm going to plot that. And let's make a nice graph. I always like to put my graphs at the top. G1 equals graph, X title equal. You don't have to put this line in there because you can make a graph with just a G curve, but I'm going to do it. X title is X, Y title is equal to F of X, and then, with the parentheses. And my width is going to be 400 pixels wide by 200 height. Height equals 200. I'm zoomed in really well, so that'll make it manageable. And then I need to make the actual thing to plot. I call it F1. It's G curve. You can give it a color. I like the color blue. Color equals color dot blue. But you could leave it blank. You just put parentheses and it'll still work. Now I want to plot those values. So I need to go through my list of X and Y, X and F values again. I can do this as for I in range length of X. So length tells me it's a number, right? How long is my list of X values? And hopefully my F values are the same. I could do length of X or length of F. They're the same, so it doesn't really matter. Colon. Now, and I do that with an I so that I can index both of those things. So now all I have to do is plot a data point for X of I and F of I. So F1 dot plot. My X value is going to be XI. My Y value is going to be FI. That's it. And it should work, but you never know. Things do break. There we go. Graph. Did it. Awesome. Happy. That's problem number 3. Problem number 3. Got it. 4. Make a new list called F2 and set it equal to FX. Okay. And this is important because we do this in finite difference. We make lists equal to each other. Now, you might want to think you actually could do this. You could do F2 equals F print F2, and it would work. But that's not what you want. And I should have said this. So it did. It printed it. Right? That's my list. But if I do it that way and I change F, it changes F2. And I don't want to do that. So instead, I'd like to do it this way. For I in range length of X, hopefully you see that before, F2I, which I don't have. So I need to just make an F2 function. So let's go up here when I make my F function. And I'm going to say F2 is equal to an empty list. And F2 equals F2 plus 0. So it has the same length. I need to start off with the same length. Otherwise, I can't do this F2I. F2I is equal to Fi. That's it. I went through each element and made it equal element by element. Instead of the whole list is equal, in which case they're pointing to the same place, and you change one of them, the other one changes too. Okay, so it looks the same, but it's not. It's different. That's question number 4. Number 5, this one's good. Find the integral of f of x from 0 to 2 and set it equal to the I. That's I. I like to do this. Okay, so we want to integrate this function. And I'm going to do it the proper way. So I'm going to take my step size dx and multiply it by the height of my function, and that will give me my tiny area element, and then I can just add all these up. But I want to do up to here, right? Because this last one, I'm going to go to there, and I don't want to, it actually would work. It'd give you the same thing since that's a 0 value right there, but I'm going to go to 1 less for my integration, right? Because I'm talking about space sizes, not values. Down here, I'm going to start off with I equals 0. That's my integration. And what I'm going to do is add stuff to I, but I need to have an I to add to. For I in range, length of x minus 1. Right? So I'm not going to go the whole way. I'm going to go 1 less. That's an integer. Now I just need to calculate my, I'll call it dA, if you want to call it dA. It's going to be my f value, which is f of I, times my dx. And then I'm going to add that, I equals I plus dA, and that's it. Print I. I'm going to put print I, I got a bunch of stuff, print I equals I, just so we can keep track of it. And there's my integration. Check. Did it. Find that. Okay. Change f2 of x so that its integral is 1. So what I'm doing is normalizing f2. I already have an f2 value. What I can do is just divide each value of f of x by I, right? And then when I go to integrate, then I should get a value of 1. Well, that's pretty easy to do. Now, normally in quantum mechanics, we'll normalize, psi star size. So the constant you'd get, you'd want to have each one go to half of those size, so it'd be 1 over the square root of it. But this is fine. Down here, I know my I value. I'm just going to go change all my f2 values. So for I in range, length of x, f2 of I is going to be f2 of I, the same value, but I'm going to divide by capital I. And I know when I say capital I, it doesn't sound like that, but it is. Now let's just integrate that and see if we get it. And I'm going to go up here and copy all this just to check, to make sure that integral is 1. And this will be, that's fine. This is f2. That's fine. And then I'll print, I'll call it I2. And let's just see if that's 1. There's a lot of stuff here that's fine. I will give you the code. Hope that makes you happy. There we go. I2 is 1. And it looks like a 12. It's not. It's I2. Okay. Check. Did that one. Should I save this code? I should. Oops. I saved something weird. I'll fix the name. Physics road test or something. Question number 7. Make a new function. Oh, this one's good. Make a new function f3 is x squared minus bx and animate it as b goes from 0 to 4 of increments of 0.1. And we do want to make animated graphs. And if you don't get this one, I should call this bonus because I don't really care about animated graphs. But I'm going to make this same graph f1, the animated graph. So down here, I'm not going to plot it. So let's just comment out this. Now let's make our new function f3. I'm going to put f3. I can build it. Let's just make it so it has the same length. Just in case. f3 equals f3 plus 0. So it starts off 0, and that's fine. But now I have an f3 function. Now I want to make an animation. So let's go through. I'm going to say b equals 0. dB equals 0.1 while b is less than 4. Do the following. Rate, let's put this rate at 50. I'm not sure how fast I'll be. And that just tells me how fast the animation is going to go. And what I want to do now is in order to make an animated graph, I need a list of data points to plot. And I'm going to add to my list and then plot it. So I'm not going to plot each point individually. I'm going to call this f data, and it's an empty list. Now I want to go through and change all my values for f3. So for I in range, length of x, I can calculate f3. f3 I equals, what did I say the function was? X squared minus bx. I just made up something. So x squared is going to be xi squared minus b times xi. b times xi. That's it. So I'm changing all my values. And now I can add that value to my list. F data equals F data plus xi f3i. And yeah, that's a lot of square brackets, but that's the way you do it, right? Because I need the double square brackets for each point is a list in a list. And then I have the square bracket for the indices. So just be careful on those lists. That's it, except now I need to increment my value of b. B equals b plus db, and then I'll do the whole thing over again. And nothing happened. What the heck? Oh, you know what I didn't do? I didn't plot it. Okay, that's fine. Fixable. At least there wasn't an error. So down here, after I add to that list, I actually have to plot the list. f1.data equals fdata. That was it. There you go. Animation. If you want to run it slower, make rate 10. If you want to make it run faster, make rate 100. The end. Ooh, that was the last question, right? Yep. So those are the questions. I'll post these questions in Google, in the comment, and then I'll post a link to the stuff down below. And you know, these are the tools we're using in Python, and we need to know and understand what these tools mean so that we can use them to do actual physics. We don't really care about lists. We want to use lists, right? So not useless, use lists. So you just got to practice these things, write it down, take notes, make your own video and of how to do this, and say this is for you, future person, and you're the future person. And when you go to Google for it, you can find your own stuff, and that would just be kind of awesome. So it's okay to forget. Okay, that's why we practice. The end.